Here we have a problem on solving logarithmic equation. In this given equation, we have to solve for x. Okay, so here in the given logarithmic equation, let me look at the stuff on the left side. So here we have log 32 to the base 2, log 16 to the base 2. So for these two logarithms in numerator, we have the base 2. And when you look at the arguments, both of them are powers of 2. So 32 is a power of 2 and 16 is also a power of 2, because 32 can be written as 2 to the 5th power and 16 can be written as 2 to the 4th power. So when I write these 32 and 16 as a power of 2, I can simplify because the base of both the logarithms in numerator over here is 2. Okay, let me write this 32 and 16 as a power of 2 in my first step. So log 2 to the 5th power to the base 2 positive, log 2 to the 4th power to the base 2 over log x to the base 2 equals to log x to the base 2. Okay, so in my next step, what I can do is here the argument of this logarithm is exponential. So whenever the argument of a logarithm is an exponential term, the exponent we have in the argument can be moved in front of the logarithm and multiplied by the logarithm. So this is the power rule of logarithm. So now I can move this exponent 5 in front of this logarithm. So when I do so, I'm getting 5 times log 2 to the base 2 positive. So the same thing I can do for this exponent 4. Then I'll be getting 4 times log 2 to the base 2 over log x to the base 2 equals to log x to the base 2. Okay, now let's consider a logarithm where the argument and base are same. So log a to the base a. So in this logarithm, the argument is a, the base is also a. So in a logarithm, whenever the argument and base are equal, so the value of such logarithm is 1, but we have to keep it in mind, the value of a over here should not be equal to 1. So except 1 for any value of a, so the value of this logarithm is equal to 1. So that means if you have log 1 to the base 1, it is not equal to 1. Actually, it is equal to 0. So always we have to keep this in mind. So when we have a logarithm where the base and the argument are same, it is equal to 1. But the value over here and here should not be 1. Okay, so here in our logarithm, the base and the argument are same. I mean, over here log 2 to the base 2, so the argument is 2, the base is 2, both of them are same, and also it's not 1. So what's the value of this logarithm? It's just 1. So we get 5 times 1 positive 4 times the same thing we have for this log 2 to the base 2, that is 1 over log x to the base 2, and on the right side we have to write this stuff as it is, that is log x to the base 2. Okay, here 5 times 1 is 5, 4 times 1 is 4. So when I add them, 5 positive 4 will become 9 over log x to the base 2 equals to log x to the base 2. Okay, now to get the denominator over here, I multiply both sides of the equation by log x to the base 2. So let me do it. So then the log x to the base 2, log x to the base 2 will cancel out, 9 equals to, so here on the right side, I multiply to same quantities. So what should I do? So I have to write log x to the base 2, the whole square. Okay, my aim is to solve for x. For that, I have to get rid of the square over here. So for that, to get rid of the square over here, I'm taking square root on both sides. So when I take square root on both sides, the square root and square will cancel out. So when I take square root for this 9 on the left side, the sign in front of the square root will be positive or negative. So on the next step, positive, in the next step, positive or negative, the square root of 9 is just 3. And on the right side, we have log x to the base 2. Okay, now let me take the equation over here. That is, I'm writing the equation, the last step of the equation over here as log x to the base 2 equals to positive or negative 3. So we can split up this equation. That is log x to the base 2 equals to 3. And here log x to the base 2 equals to negative 3. So I'm writing this equation one time for the positive 3 and another time for negative 3 on the right side. Okay, so our aim is to solve for x. Actually, here we have two logarithmic equations. So to solve for x, what I need to do is I have to convert these two logarithmic equations to exponential form. So how can I convert these two logarithmic equations to exponential form? It's very simple. On the left side, we have log to the base 2 here. It has to be moved to the right side. So when I move it to the right side, I'll have only x on the left side. When I move this log to the base 2 to the left side, I have to consider only the base 2 on the other side. The value which already exists on the other side will become exponent of this base. So this is how we have to convert a logarithmic equation to exponential form. Then I'm getting x equals to 2 to the third power is 8. The same thing. So I have to move this log with base 2 to the right side of the equation. So then I have x on the left side. So when I move this log to the base 2 to the right side of the equation, I have to consider only the base 2 on the other side, and the value which already exists on the other side will become the exponent of this space. And further, this 2 to the negative third power can be written as 1 over 2 cube. And in the next step, 1 over the value of 2 cube is 8. So I'm getting two values for x. One is x equals to 8, another one is x equals to 1 over 8. Since it's a logarithmic equation, and we have to make sure whether both the values of x will work with the given equation. Actually, x is being as an argument of the logarithm over here and here. So already we know that the argument of a logarithm can never be a negative value or 0. Always the argument of a logarithm has to be greater than 0. So here the argument of the logarithm over here and here, both of them are x. Since x is being an argument of a logarithm, x has to be greater than 0. The values, the two values which I got for x over here, both of them are positive. I mean, both of them are greater than 0. So both the values of x can be accepted. So therefore, the value of x equals to 8 or 1 over 8.